Hi everyone, welcome back. We are in Module 2. We are in Topic 1. We are on Lesson 2. And we are on the first day of it, Session 1. So Lesson 2, Going Strong. Today our key terms, qualitative reasoning and quantitative reasoning. We're going to talk about those in just a second. Our goals, apply qualitative ratio reasoning to compare ratios in the real world and mathematical problems. And same thing with quantitative reasoning. Compare and order part to part and part to whole ratios represented verbally, pictorially, and numerically. So in words, numbers, pictures. Qualitative reasoning is when you make decisions and you reason about something without using numbers. Quantitative reasoning is when you do use numbers to do that. And that's kind of what they're asking us to do down here in the review. It says use reasoning to compare the fractions in each pair. Now, so we need to say if they're equal, less than, greater than. And I want to start actually with number 3. I kind of wish they were in reverse order. So if we have 4/5 and 4/3, and we need to tell which is greater, using qualitative reasoning, I can, without numerically figuring anything out, I can look at this and I know that 4/3 is greater than 1 whole. So 4/5 is less than 1 whole. So I automatically know that 4/5 is less than 4/3. Same with this one, number 2, 7/13 and 5/11. These are both kind of around half, but if I think about half of 13 is 6.5. So if it was 6.5 out of 13, that would be equal to exactly 1/2. If it was 5.5 out of 11, that would be equal to 1/2. This one is lower than the 5.5, and this one, the 7, is greater. So because this is greater than the 1/2 value, the 6.5, we know that entire fraction is greater. And then we have 6/7 and 8/9. And this one's a little bit trickier to do because they are both 1 away from a whole for whatever the whole value is. Here a whole is 7, here a whole is out of 9. So for this one, quantitatively, I can find a common denominator, and I can just multiply the two together. 9 times 7 is 63. So then I ask, how do I go from 7 to 63? Well, I multiply by 9, which is what I did here. So 6 times 9 gives me 54. So this one, to go from 9 to 63, I did it times 7. This one over here was a times 9. So 8 times 7 is 56. My brain can think one thing and write another. So we have 54 63rds and 56 63rds. So those are very close, but we have this one here. I do want to take a moment and show you a little shortcut with this. When comparing fractions, if I just multiply like this, 9 times 6 is 54, which is what I got here, because I'm multiplying both of these by the 9. 7 times 8 gives me the 56, which is what I had here. So I can really just kind of multiply on the diagonal if I want to compare them. I don't know why this is so poorly showing up here. I'm going to pause for a moment. Well, I cleaned off the camera, but it is still quite blurry. So I'm just going to, I guess, write over this. 4/5 greater than 4/3. The 7/13 is greater than, and in this one, the 6/7 is greater than the 8, or less than the 8/9. Okay, moving on. So now that was page 183. We're going to move on to page 184, the getting started. So it says Lemonier lemonade. The shaded portion in each glass represents an amount of lemonade. Read each situation and answer the question. Explain your reasoning. It says Tammy's glass of lemonade has a weaker tasting lemon flavor than Jen's glass of lemonade. If you add 1 teaspoon of lemon mix to both Jen and Tammy's glasses, which glass will contain the lemonade with the stronger flavor? Okay, so why don't you pause and think about that for a minute. See if you can write something down before I just kind of go on here and go over that. Okay, so as I think about this, I like to write some things down so that I can kind of have a visual with what I'm thinking about. So it says Tammy's glass is weaker. So I'm just going to write it's weaker. So this one is stronger. So this one tastes less lemony than this one. If you add 1 teaspoon of lemon mix to both, so we're going to add 1 to both, which glass will contain the lemonade with the stronger flavor? Well, if we're adding an equal amount to each, then it doesn't really change which one is weaker or stronger because we added a consistent amount. So Jen's glass will be stronger. And we can say it was stronger initially or to start. The same amount was added to each. So hers will remain stronger. And pause as you need. Beth's glass of lemonade has a weaker tasting lemon flavor than John's glass of lemonade. Okay, so Beth's is weaker than John, so his is stronger. If you add 2 ounces of water to Beth's glass and 1 teaspoon of lemon mix to John's glass, which glass will contain the lemonade with the stronger lemon flavor? So we're adding 2 ounces of water. And here we're adding 1 teaspoon of lemon mix. Well, this one's already stronger and we're adding lemon mix. This one was weaker and we're adding water. So what does water do to any of these? Like if we add water to anything, it's going to make it taste weaker. So John's glass still has the stronger lemon flavor. John's will be stronger. We can say adding water to Beth's makes it even weaker than it was while adding lemon makes John's even stronger. Jimmy and Jake have glasses of lemonade that taste the same. Okay, so they're the same. Same strength. If you add 1 teaspoon of lemon mix to each glass, which glass will contain the lemonade with the stronger flavor? So add 1, add 1. So which one will taste stronger? Neither. Since they started the same, we'll say since they started with the same strength, and the same amount was added, they both remain the same strength as compared to each other. Okay. Slide that up there so you can get that copied. And then you can go ahead and hit pause so that you can finish. I'm going to hop onto a new video.